This, I don't know if you see it, is 876. And if we look here at the process 876, we can see it's running under system account. But the process we are looking now is running under network service account. So when I saw this, this was weird because we can see that a process running under a low privileged account is handling a handle from a high privileged account. So I ran Windows Debugger, tried to look at what permissions this service, the telephony service, has for this process handle. And I found out something interesting. So I debug. You can display all the handles opened with Windows Debugger. And you can see here the handles. One of the handles is the handle for the process itself. And the other handle is for the process that is running under the local system account. And you can see here it has granted access to dup handle. That means duplicate handle access. It means that this process can duplicate any handle from the other process that is running under a high privileged account. So it's very easy for this process to elevate privileges because it can duplicate a local system handle for the other process, or it can duplicate a thread and modify the thread and execute code. It can do almost anything in the other process because it can get any handle from the other process. So this is an issue, but it's not important because in order to exploit this, first you have to exploit something in the telephony service. So when I was looking at Windows 7 with Process Explorer, I decided to concentrate on this service, the TAPI service, the telephony service, and find out if I could find anything more that allowed me to exploit this issue to elevate privileges. So there is another tool called Process Monitor. It's also a very nice tool and powerful. It monitors all system activity related with registry access, file system access, network access, all one in one tool. And you can make filters to filter by process ID, by the path of the file or the registry key is accessing. You can filter by process name. There's a lot of options to filter the system activity. So I ran Process Monitor and filter by the process ID of the telephony service. So this will allow me to look mostly inside what the telephony service does, what registry key it access, what file it access. But in order to look at the activity performed by telephony service, I have to interact with it. So I decided to stop and start the service to see what was happening when the service stopped and started. So you can see there, I stopped the service and Process Monitor is capturing activity. And then when I started the services, more activity is captured by Process Monitor. So looking at the capture, there is a lot of information there. If you are familiar with Windows, you can identify some files, some common registry access, registry values and keys. So there was a registry key that got my attention. The subkeys H key, local machine software, Microsoft tracing, TAPI SRB. I have never saw before that key, so it got my attention. So I ran Registry Monitor to look at the content of the registry key. And the first thing that came to my mind was to check the permission of the key to see what were the permissions. That was because, as I said, the processes on Windows 7 has special permissions. And when I look here at the permission of the key, it was a surprise there because you can see there we have network service, local service and users account on the ACL of the key. And they all have special permissions. And when we go to see what are those special permissions, we can see that those accounts has the set value permissions. That means that all those accounts can change any value on those registry key. So you may be wondering what is the issue. The issue is that these registry keys are read by a high privileged service that is running on the network service account. Any user can change a value that will be read by these services. So there is a possibility of elevation of privileges there. So I continue looking at the key to see if this could be exploited, this weak permission could be exploited in some way. So I started to look at the value of the key. I started to look at the different sub-key also here. And you can see many familiars names. They are named of other services or other processes. So I started to think that there was some kind of functionality that was used by some services and processes. Then looking at the value, I found this interesting value called file directory. And this value had a path in it, windir/tracing. So I went to look at Process Explorer, what this directory content was, and there was nothing there. So I continued looking at the key values, and I found another interesting value called enable file tracing. It was almost self-describing what this value does. So it has a value of 0. And the name of the value is enable file tracing. So I decided, okay, what will happen if I put this value on 1? So I set the value to 1. I changed the value. And then I look at Process Monitor to see if something happened. So Process Monitor in background still was capturing the activity. And you can see there at the end, a file being created in the directory that was specified by the other registry value. So later, with more research, I noticed that the services that implement this feature for tracing, this is a feature that enables services to log information related with the bug information, error, etc. This functionality also keeps monitoring the registry key. So anytime you change any value over that key, the service will instantly read the value and act accordingly to the code. In this case, I enabled the file tracing, the tracing functionality, and it instantly read the value and created the file for logging. So when I saw this, I started to think that it was exploitable, and it was very easy to exploit. Those who knows about Windows local exploitation maybe will be familiar how to exploit this. It's about using a name pipe trick, because we can change a file directory name. So we can set a name pipe there. And if you remember the APIs I mentioned for impersonation, there is a impersonate name pipe client API. So you can impersonate over name pipe. So you can create a small program that will create a name pipe, will listen on the pipe, waiting for a connection. And because here we can force a connection to a name pipe, when the connection is established by the service, we can impersonate the service. Of course, we'll need impersonation privileges, so this only can be exploited by user with that privileges. So here I did a test. You can see the file that was created there. So I changed the file directory value for a name pipe. So I set the name pipe. In the background, Process Monitor was still captured. And then when looking at the capture, there you can see the service tried to access the pipe. So after doing some tests, I confirmed that it was exploitable. So if you remember, the telephony service has a process handle from a high privileged process. So in this way, I can get from any other process, for instance, running on the network service account or local service account or an account that can impersonate, I can get inside telephony service, and from telephony service, using the process handle from the high privileged account, I can elevate to system. It's a two-stage attack, but it works and it's very easy. And allows me to bypass the protection, the new protections. So, like I said, it was in the way I described it, it's a two-stage attack. So, because I saw in the registry key some familiar names of other services, I thought, why not to look for a service that is running under the network service, the local system account. So I can just impersonate directly the local system account from the name pipe. So I found the IP HLP SBC subkey, and that reminded me IP helper service. I have seen it before, so I went to Process Explorer looking for the IP helper service, and I found it. And I found that it was running under the SBC host process, and this SBC host process was running under the system account. So I could use the name pipe trick to directly impersonate that system account and elevate privileges. So that attack got a lot easier, just one stage attack. You can see there IP helper service running together with a lot of more services inside a SBC host process. So the weak registry permission issue allowed me to any user with impersonation rights to be able to elevate to system. And well, I did some tests. I enabled file tracing with the IP helper service and looking at process monitor, and also at the file creation in the tracing directory. You can see there the log file is being created after enabling tracing. So now let's see an exploit. It's a pretty simple exploit, like I said. Let me show you the code. It will work on Windows, on Internet Information Service 7, 7.5, SQL Server, any service that can impersonate or any process that can impersonate will work. This exploit is called chimichurri, which is an Argentinian sauce for churrasco asado. Well, basically the exploit will create a name pipe. We'll create a thread. Let's insert this thread. So the thread will create a pipe, name it with including the file name of the file that the service will create with the file tracing is enabled. We'll create this pipe, and we'll start to listen on the pipe, waiting for connections. And when it gets a connection here, it returns from this API call, and it will try to impersonate. After impersonate, it will get a token, the impersonation token here, open3 token, get the impersonation token, and then we'll use that impersonation token to create a reverse shell running under the system account. This is the function to trigger the vulnerability. We open the key and set the